Okay, let's do an application of the area of a circle. I've got a fun looking problem here. It says the diameter of the center of a circular 3-lane auto racetrack is 450 feet. So we have a 3-lane racetrack. So we have a small little circle here. Well, let's do that. And then we have that one there. And then we have this one. And then we have this one. Okay, let's see when that looks about right. So yeah, so this is a 3-lane. This would be, we have a 3-lane racetrack. Here is lane 1. It's called L1. Here's lane 2. And here is lane 3. Okay? That's our 3-lane racetrack. And here in the center, that's the little center, that's the grassy area. And we know that we're told that it has a diameter. So it's a language here. The diameter is all the way across is 450. Okay? And we're told that each lane has a width of 40 feet. So we have an additional width here of 40 feet. We have an additional width there of 40 feet. And we have an additional width there of 40 feet. And so the question is, what is the area? What is the area of the racetrack? Okay, and so this thing's a big circle, so we know that the area of any circle equals pi r squared, where we're going to approximate pi to 3.14, and note that r squared means times r, where r is the radius. Now I have to find the radius. Let's draw a picture of what the radius is. The radius is the center out to the end. So we have to determine what that radius is. So that's going to be my mission. What is the radius? So we know from the tracks are out. This is 40, that's 40, that's 40. So it's going to be 40 plus 40 plus 40 plus, and the trick here is going to note that this is not for this one, for that distance it's not going to be 450 because 450 is the diameter. The radius is always half of the diameter. So this little circle here, we're told that it has a diameter of 450, so it has a radius of half that, and so 1/2 times 450. Okay, and that's going to equal, please excuse my dear Aunt Sally, we have to multiply before we can do any adding. So we got 40 plus 40 plus 40 plus 1/2 times 450, and any time we multiply by a fraction, let's write everything as a fraction. That's 450 over 1. 1 times 450 is 450, and 2 times 1 is 2. That equals 40 plus 40 plus 40 plus, and let's get the calculator out. Tools, calculator. 450 divided by 2. Let me clear everything out. 450 divided by 2. Alright, 225 plus 225. Okay? So this equals, so clear everything out, 40 plus 40 plus 40 plus 225 equals 345. 345. And note that all these were in, these are 450 feet here, so the radius is 225 feet. These are in 40 feet, 40 feet, 40 feet. So when we add everything up, we got 345 feet. Okay, so that's the radius. Now to find the area of the whole thing, let's go back to green. Area equals pi r squared up there, and we got 3.14 times 345 feet times 345 feet, and that looks like a job for the calculator. Let's see, tools, calculator, so let's go 345 times 345. That gives me my square feet, and then times 3.14, 617,481. 617,481. Just multiplying straight across. 3.14 times 345. Take that number you get, multiply by 345 again. The feet times the feet gives me my area, the square feet, and that's going to be the final answer. So again, remember the trick here was that they told us that the circumference, or that the diameter of this center circle was 450. So to get this problem correct, we had to make sure that we know when we're talking about area, we're not interested in diameters. We need to know the radius. So the radius is always equals the diameter divided by 2, and that was that expression right there where we utilized that. And that will conclude this podcast on an application of the area of a circle.